plan here is there really is no plan. The idea is that we're here, we're available to answer questions. As people join, we can kind of take the discussion anywhere we want. And if there's not too much live questions going on, we can look at Discord and go into some of the questions that have popped up there. We can also just find some topics to talk about and use this time in some way. So I guess we got one caller on the call.
Morning, Neil.
Yeah, bright and early for some of us, and I guess maybe late night for others, depending on your time zone. So thanks everybody for making the time work. But yeah, so I guess anyone who's joined here, feel free to hop into the question either in the chat or unmute and go ahead and ask. But if not, we can maybe jump over to Discord and start there.
Yeah, cool.
So there was an interesting question that came up yesterday, or I guess overnight, from user Bruno Zell. Let me see if I can share screen here. Okay, can you guys see my screen?
Yes.
Great. So yeah, here's a question from Bruno Zell. I think this is an interesting one, actually. So what he's saying here is, he wants his metagraph to ingest data from other metagraphs, so some sort of an arbitrary list of other metagraphs. He's looked at the possibility of running a daemon within his L0 nodes that wakes up on some sort of a schedule and fetches data. And so he's looked at here first the alpaca metagraph example, which I think is a good one to look at for this. But so the ultimate question is there a way to make this run once for every snapshot of some arbitrary external metagraph and sync or run some sort of action that's triggered at that level or that time scale?
So reading through the question, it's a really interesting prospect, but there's a couple of things that come to mind here. First, to answer his question about the snapshot ordinals, the global snapshot ordinal is common across all, like it would be the same between any metagraph. The currency snapshot ordinal is specific to a metagraph, though. So there may be an issue with trying to trigger off of the snapshots produced, like the snapshots of other metagraphs. It'd be better to try to read the global snapshot as new global snapshots come in and that ordinal's progressed, to read those things. The bigger challenge that I think this would face, or this implementation would face, is that the payloads for these data applications that are resolved down to the global layer are arbitrary byte payloads. So because we allow each metagraph to define their own serialization schemes to support whatever format, XML, JSON, CBOR, whatever serialization format they desire, that means that there's not one common way to read the data from other metagraphs. So this aggregating metagraph would need to know the serialization schemes used by the other metagraphs in order to, whenever, if it's polling the global snapshots and it sees a new snapshot from, metagraph A come in, the aggregate metagraph will have to get that payload from metagraph A, deserialize it into the object according to the rules that it would know how to do, and then read the value out that it, and then embed that into the aggregate metagraph state.
Yeah. So one potential strategy would be to try to read every global snapshot, look within the snapshot under this state channel snapshots key, and you can see every state channel or every metagraph snapshot from other metagraphs that's been incorporated to that global snapshot. The problem becomes you can't deserialize those metagraph snapshots without having some sort of knowledge about how that metagraph has chosen to serialize their data. If they use the default, then it would be simple, but you can't necessarily assume that that's going to be the case. So maybe another strategy would be to, reach out to those metagraphs over HTTP and fetch snapshots directly.
My idea right here is like we definitely should fetch from global snapshots, because there is the snapshot that was propagated as a global layer and was accepted by the global networks. And once we have that ordinals, you probably need to build on your aggregated metagraphs the custom routes that will fetch the payload, like the state, per ordinal. So maybe you can have a mechanism to store your calculated state or on-chain state per ordinal. And then you can create custom routes that will return the current state per ordinal. Because like the guys mentioned, it's almost impossible. So you can try to deserialize all the possible ways that metagraphs can serialize data. So I think that this part of deserialization and serialization should only belongs to the metagraph owner. So probably these other metagraphs can expose HTTP routes that will return per ordinal the information that you need.
So maybe for me to jump in here, I'm the one who asked the question, by the way. So, so basically, I think for the hackathon, it's definitely good enough to just have like querying the data through custom HTTP routes. Currently, anybody can declare a variable in my metagraph that links to a set of layer 0 URLs and a data path, and that is then just fetched in the daemons of the hackathon metagraph, where currently at some interval, like that layer 0 endpoint is fetched through HTTP, and we just assume that the data is valid, right? Because it was the correct layer 0 node URL. I guess also the requirement is that it has like a specific like JSON format, so it parses down to a number. It doesn't support anything else at this point. Maybe it's a next step, maybe support other primitive types, or some custom parsing logic, something like that. But that's definitely out of scope for the hackathon here. I'm just wondering right now more about the consistency, like the item potency of this, because it's currently, I guess, if I run this as a daemon, every layer 0 node would fetch the HTTP endpoint. And if I don't have the ordinal at the request, it could result in different values, right? And then the metagraph that all the data is imported to might have difficulties to decide what the value of the variable is at a given snapshot. That's really the thing I'm not sure about here. I mean, I guess we can ultimately just currently I just program it so that if there are multiple fetches and they are different, then all of them are discarded. So only if the variable is updated if every layer 0 nodes have fetched the same value. And I've tried to coordinate it so that, like with timing and stuff, somehow this works. But, like maybe there's a better solution that I just don't know, like with fixing all the nodes somehow, maybe.
So, because I think one thing that comes to mind is that you would need to have some sort of a counter for each metagraph, so you know what ordinal each one is on, or what you're up to date to for that metagraph. I guess is that sort of the question of like, how do you keep in sync with the external metagraphs?
Yeah, in a way, or at least to don't stall the metagraph where it is imported to. So currently, I'm imagining a schema of everybody being able to pose a variable that is to be tracked, where there's a functional key of the metagraph address where the data kind of comes from in a validated way, and then there is ideally some abstract layer 0 query which reduces the state to a single value, and at every snapshot we can call this layer 0 query on that metagraph and reduce the whole metagraph state down to the variable value. Like this would be the ideal goal here, so that then the metagraph just tracks individual variables that are automatically fetched from the whole Constellation network in a way. Yeah, that's a goal, and whatever is the simplest, I guess, works for the hackathon. I basically want to use all of the different possible metagraphs as a source of observations for causal models. So I don't care about how you validate the data. I just want a data stream that is validated in some way, and then the metagraph that I'm building, figures out how the data got generated through causal modeling. But essentially, I want to, tap into other metagraphs, validated data streams in a way.
So there is the method on snapshot consensus result. So the easier way that I could see is if you can coordinate with the other metagraphs, it's for the external metagraphs to push data to the aggregate metagraph. And the easiest way I could think to do that is the source metagraphs would put a method in their on snapshot consensus results implementation that would, when a new snapshot comes in, you have the list of updates, and you could figure out what the ordinal is for that metagraph, and you could then just call an HTTP method to the aggregate metagraph to like alert it to say, hey, metagraph A, source A has a new value, and here's the snapshot, and here's the new value for it. And then the aggregate could just track that through its requests.
Yeah, but we definitely
Holding the other
use-
metagraphs, I think you could get out of sync really quickly. Sorry, Marcus, go ahead.
No, I think that it can work like if we have on after snapshot consensus send to the aggregator metagraph, but there has had a new complexity because you need to take care, because after snapshot consensus is after current snapshot consensus, and maybe your snapshot consensus doesn't reach the global 0 layer. It can be sending to one healthy node, or it can be sending to exceeding the 500 kilobytes. So we have some conditions that reject their snapshots. So you will probably need to add to the aggregator metagraph a way to verify if the incoming snapshot was accepted by the global layer and it was the official one. So it's possible, instead of having workers that pulls data from the source metagraphs, you can have like the source metagraph sending data to the aggregator instead of pulling. It works like a WebSocket that will send data for you. We will just need maybe to add the generic data update type that can, like, all the source metagraphs will send this exactly same data schema. Like, of course, the data will be different, but the same schema. But yeah, you need to add this new security question to verify if the metagraph, if the snapshot is valid on the global layer. Because that's another thing that I want to let you know, is because one global snapshot can receive multiple currency snapshot at the same metagraph. So your metagraph can send 3-4 snapshots to a single global snapshot. So you can see, like, if you fetch the ordinal 10 on global, then if you fetch 11, it can be that on snapshot 10, your currency snapshot, it was 1. And on the global snapshot 11, your currency snapshot, it was 15, as an example. You send 15 snapshots in one single global snapshot. So you need to take care, because we can't send multiple currency snapshots at the same global one. There's another attention point.
All right, cool. Yeah, I think I got a good overview now of what I can do here. So yeah, I think I'll just go back and hack something up and try to figure something out.
I guess,
Thank you.
but yeah, I guess your idea would be to kind of aggregate from all other metagraphs. You don't want to coordinate with those metagraphs to be providing any particular information, right? You just want to sort of suck up all the information you can.
Ideally, like we are basically trying to use a constellation or any possible metagraph that may not be defined yet as a oracle source in a way, right? Where we trust the validation rules of whatever metagraph you point to, and that is what we use as the data input then. Yeah, that's pretty much it. And
Yeah.
then once the values are imported, then we kind of do computations on them in the general purpose metagraph.
So if that's the case, it sounds like probably a push-based solution from other metagraphs wouldn't really solve it. So what I would suggest is just taking a look at, so this is, I've just got Postman up. We're just calling the latest global snapshot on mainnet. But if you haven't done this already, sort of check out how these currency snapshots or the Metagraph snapshots are stored within the global snapshot. Because this is going to have every single accepted Metagraph snapshot when it's finalized. So what you end up with is this format where you can validate what the previous snapshot was, so you can figure out the lineage and that you're on the correct chain, fee information, and then this is what we were talking about, the content. This is the serialized portion of the data application. I believe by default, maybe someone correct me, this would be base 64 encoded. So completely deserializable. So for Door, you could just deserialize this. But Metagraph developers do have hooks into that is the serialized snapshot or serialized data hook. So you could encrypt it, right? So you can't say 100% you'll be able to decrypt all of these snapshot content or all of the content of these snapshots. But in the common case, you likely would be able to. So that might be somewhere to start. And if you sort of knew the deserialization method for different metagraphs, you could potentially keep that state somewhere within your local.
I think that has he already opened Postman, Alex, maybe it's worth to mention that only for the latest, we can call the / combine it at the end on the URL. So you can check the details about the currency snapshot. So on the URL, can you hit Alex, please? / combine it. It's a little heavier because it aggregates the state, but it works. So if you search about the ID of Door Metagraph, like the CUM at the end, you can search there. You can see at the bottom the information.
Okay, so basically the global snapshot has multiple snapshots, and this one just merges all of them into the latest aggregated one.
Yeah, like the global snapshot aggregates all the currency snapshots.
Regarding the Door metagraph, since this is something that's already live, is there any data that I can fetch from the layer 0 data specifically, or any location data I can maybe get my hands on or something to work with? Some as an example, or I haven't looked into the Door metagraph specifically yet, but maybe there's some data source that I can grab, or it's all like encrypted sent to Door. Like, I don't know. That's a question.
Yeah, so the event data itself is removed from the data update before it makes it on chain for Door. So that's on purpose so that that data can later be sold essentially. So if we make it fully public, then you can't sell it. But its hash is stored on chain, so we can then prove provenance of the data if we provide the raw data with the signed hash. So maybe Marcus, what data do we have available on the Door Metagraph?
We have the calculated state. That's the only thing that we have on custom endpoints. Like we can get the IP of Door mainnet and then hit data application, calculate. Let me just confirm the exactly wrote.
Right, but then alpaca metagraph, right? I mean, there are some public variables I can already like take as an input, I guess. And then for the
Yeah.
hackathon, I'll just create some like super simple like data example metagraph that I guess gets a point across. But you know, the general purpose metagraph should is the actual submission, right? So I guess it just needs to
I,
wait
I
for
recommend
data
you
sources.
to I recommend you to use the alpaca, because alpaca we have different data sources and different data per data source. So it's public there, and you can use the data from alpaca. It's way more readable than Door, and maybe it's easier to use.
All right. Yeah. I think I got a good picture of how everything will work. The global snapshot actually, that was a good insight. I didn't need that, and you know the patching of Metagraph snapshot and all the
Yeah,
ordinals. So
the
yeah.
other one, Alex, above one, like the search tree. Yeah, this is the last ordinal
Oh,
accepted by the global layer. So there is the copy of your snapshot that you sent to the global layer. So you can see the ordinal last snapshot hash. So this is your snapshot that the global layer accepted. So this is the source of truth. So let's say that your currency snapshot, it can be like in the final 860, but it wasn't accepted by the global layer yet. So the official one is this one.
Yeah, in terms of potential syncing issues or whatnot.
Yeah.
you mean there are multiple like forks that are incompatible? What is that?
No,
Was that
like
what you're saying?
we have the currency running, and then the currency sends snapshots to the global layer
Mhm.
during this period. We can have synchronization issues. So let's say that
Mhm.
you send your snapshot to the global layer, but the node that that have received your snapshots become unhealthy, or this node was forked somehow. So your snapshot will never reach the global layer. So we'll kind of get out of sync, and that's what we have the monitoring service that will detect this for you, and then we start your metagraph and put in the right chain again.
Oh, okay, interesting. So so if I kind of mess up with my validation rules and anybody creates a variable that cannot be queried idempotently, it's still not in the consensus, but at least the metagraph keeps running. Yeah, kind of. I guess.
Yeah, the ML0 nodes are going to pass around a snapshot. They're going to propose a snapshot and then try to get it signed. And once you get a snapshot with the majority of signatures on it, so if you have 3 nodes, once 2 of those nodes sign that snapshot, then the global layer will accept it into the global snapshot as like the next state of the state transition for the metagraph. But right, that third node might have disagreed and had a different state, and so then it gets forked and it has to like backtrack.
Oh, look, I thought we had a diagram that would be helpful here, but yeah, if you just think of, this isn't the best diagram for this, but like if we think of our minimal metagraph as 3 nodes, each of those will be sending their snapshots to the global 0. And so there can be synchronization issues around that. And sort of anyways, just adding on this sort of this visual of, you know, if you think about the metagraph as 3 nodes separated from the global 0, sending its metagraph snapshots to the global 0, there are, you know, syncing issues possible there. There's hey, we can't reach the global 0, so it's not accepted, or you reach a forked node and whatnot. So you just have to kind of think about, you know, did my snapshot actually get accepted, and was it the right one?
Yeah,
Yeah,
think about the
I think I
metagraph.
have a
Yeah, go ahead.
yeah, I think I have a pretty good understanding of how the individual metagraphs have consensus routes where they compress usually the data down to hashes, which are then submitted to the global snapshot where there's another consensus round. And only after this is done, then the other metagraphs can basically read the consensus state back in. And there's this like little latency going on of maybe like, I don't know, a few seconds or minutes until the data kind of circles around in metagraphs. And even then the shared state is only usually hashes of the actual underlying computed state. So in a way, once we want to extract more data out of other metagraphs, we would need to know about the schema of that specific metagraph and the computed state to essentially map the on-chain snapshot state to the computed state, and then to even interpret the computed state at all to extract information from it. Right.
Yeah, exactly. And then so far, I believe in Door and I know for sure in the Alpaca Metagraph, you can just look at in the source code. We're just using JSON serialization. So we take the state, like the in-memory object, the class, we go to JSON, and then we just turn that JSON into an array of bytes. So you could just copy that JSON serializer to be able to like take the array of bytes from the global snapshot and reserialize it back into an in-memory object.
Yeah,
Yeah.
the door metagraph, when I built the metagraph, we haven't, I remember that we didn't have yet the JSON serializer, so the Alpaca one is using this class, but the door metagraph is just mimic the Alpaca one, so the behavior is the same. It's just getting transformed to JSON and byte array it, and then the reverse, byte array to JSON and class. So it's pretty much the same.
Hey guys, well, looks like we've got a number of folks have joined. I actually didn't see. I was sharing screen, so welcome everybody else. Are there any other questions we can jump to from anyone else in the group? All right. Cool. Well, yeah, if anyone has questions, feel free to drop them in the chat. Kevin says just wants to drop and say hi. Hey, Kevin. And then from Lalit, we have, how about a web app based adopter outside the two metagraphs? How would that interface with kind of the same problem?
Yeah,
So,
basically.
Yeah, go ahead, James.
I was going to say it's basically going to face the same problems that the aggregator metagraph would face. Sorry, but go ahead.
Yeah, and that they would essentially have access to the same tools. So that external app could be fetching from the global APIs and pulling in the global snapshot, parsing it, or could be fetching from individual metagraphs if they had some sort of a custom endpoint set up. It could use that also. So external indexers work just as well. All right. Yeah, anyone feel free to jump in if you've got another question. Otherwise, we can maybe just go over some kind of general gotchas, general things to kind of consider that maybe aren't obvious. Does anyone have one? Or James or Marcus?
Yeah, I wanted to just bring up a question that I've seen a couple of times during the hackathon, that Euclid is a really great way to build the project and start to test and do like runtime testing. But one of the benefits of using Scala and the strict type safety is that during development, you can kind of lean on the compiler to make sure that things are wired up correctly. And so if you can't even compile, right, that gives you at least that first round of troubleshooting to go after. But when you're trying to do that in like IntelliJ through your IDE, the tessellation dependencies aren't available as they're currently just not published to Maven. So you have to manually build them. And so sometimes you'll see if you pull in your Metagraph project or like one of the examples into an IDE and you try to build it, it says it can't find the tessellation dependencies. And it's a pretty simple solution in that you just have to go clone the tessellation repository as well, and then do SBT publish local. And when you publish local, it'll actually build all the dependencies and then put them in your like local cache, all the jar files and make them available for your Metagraph. Whenever it goes to compile, it can find all the dependencies it needs. So yeah, it's just it's kind of, there's a lot of hoops that have to jump through to get artifacts onto Maven. So we
I've already
haven't
heard
made that
this. I've already heard this question as well. Like if you want to develop locally, like James has told, you can take a look at the Docker file on the Euclid. There we have the instructions, like at least the Metagraph Ubuntu based image there, Docker file. We have the instruction to generate the local dependencies from Constellation. It's a SBT command, like of course that we can publish local, like James has mentioned. But if you want to publish only the specific modules necessary for using Metagraph, we have the exact instruction there to clean and publish everything. But here is another gotcha. I believe that you have faced it as well, James, that when you are publishing locally and when you are syncing to your Metagraph, you probably will need to put your GitHub token to publish locally. And because if you try to do the command to publish locally and syncing on your Metagraph, and if you haven't set your token locally yet, you will probably face an issue saying that you are missing GitHub token. This is a requirement that you need to do. And another gotcha about this part is like for every version of Constellation that you will try to use. So let's say that you are building your Metagraph on 2.8.0 version, and then you want to update the 2.10.0 version. It's required that you run again the publish. Like for every version, you need to generate the dependencies again. And let's say that you want to generate the same dependency again, you need to delete locally and then generate again, because it will not override for you. This is just simple tips that if you face that issues, and this is just for local development. After your test locally, if you prefer it this way, you definitely need to use the Euclid to build and publish your Metagraph locally, because it's possible to do outside Euclid, but it's pretty hard. So we recommend you can try to develop locally, but then use Euclid to publish and let our Metagraph running in development mode.
And the GitHub, just to mention, the GitHub token that you have to put into your environment, it is the same GitHub token that you would put into your Euclid JSON. You just have to, honestly, the reason it's in Euclid JSON is because Euclid puts that token, whenever it's building all the images, it puts the token into the build environment for you. And so if you want to do local development, you just have to manually put that token into the environment. And I was just about to put a message with the commands you can use to do that. It's really just like export GitHub token equals and then the value. And then you can confirm by doing echo $sign GitHub token.
I've already seen situations where we export the variable, just like you have mentioned it works like if you operate at the same terminal, but sometimes the IntelliJ simply don't catch by the terminal, and then if you try to build using the SBT of the IDE, it will fail. So at this situation, you probably need to set up your GitHub token at your Git credentials that the IntelliJ will use. So you can go to the documentation of IntelliJ and see how to do this. It's just like syncing your GitHub token with the IntelliJ IDE. It's a little harder, but it works. But if you prefer to operate directly on terminal, the solution that James provided, it's enough. It's pretty good.
Yeah, I think you can also put in your bash profile, or like your shell profile, like your Zesh profile or your bash profile. And it just like automatically exports that token every time you make a new shell.
Yeah.
And the field in the Euclid JSON, I just leave it blank then?
You'd want to still have that field as well, but the Euclid JSON is only used whenever you're running the Hydra scripts to build the containers. But so this is for doing like local development. If you just want to use SBT directly on your local environment.
Think about this in two steps. Like this step that we are mentioning is the previous step in Euclid, where we are trying to build your Metagraph locally to see if it compiles. And if it compiles, you want to test in official cluster, you just copy your project, send to Euclid, and then Euclid will put your Metagraph online with the complete layers and complete nodes. And you need the SBT in both places because you use locally to compile your project, but you will definitely need to generate your nodes because your nodes will run the jar and will, of course, have the dependencies locally as well. And so you probably will need, you definitely will need the GitHub token in both places.
So maybe on another topic here about token distribution, what capabilities do we have or what we can do? Because although for the hackathon, there's not really the ability there to distribute tokens as it's developed locally. We do have the ability for submissions with tokenomics. So if you guys could talk a little bit about how what capabilities we have for airdrops or for distributing rewards, I think that would be interesting.
Yeah, I think that's a good one because minting tokens is actually very simple using the rewards function, but there's some gotchas around it. And I think it is one of the things that makes Metagraphs really easy to use for certain use cases is that minting incurs no fee, right? So you can mint tokens on demand, like what Door is doing or what Alpaca is doing. But maybe Marcus, you want to talk on that one?
Yeah, sure. I will start and then you can complete, James, at this part. Like to mint tokens and distribute, you don't need the data layer if you don't want to. Like if you want only a currency snapshot for only tokens, you can run the currency L0 and currency L1 layer. We have on the L0 and L1 modules. On L1, we have the validate rewards or something. I forget exactly the name of the function, but we have a function that validate the rewards there or transactions. And then we also have on L0, the function called rewards. So this function, it will be called at some point of the consensus. And then this function will be called to distribute the reward for the current snapshot. So on this function, you can see on the signature that we have a few parameters like the type of snapshot. It can be event trigger, like the snapshot can be triggered by an event, or it can be time triggered that should be triggered at every 43 seconds that we call epoch promise. So on that function, we can decide like the output of this function is an array of sorted transactions, the reward transactions, sorry. Yes, exactly this function. The output of this function should have the reward that you want to distribute. This function is, you can open the door rewards.make, that maybe can make more sense, Alex. Door rewards, exactly. Yes, this one. Let me just take a look. Yeah, the output here is gonna be this list that we need to provide the address that we want to pay the tokens and the amount of tokens that we want to pay. So at the door case, you can take a look at the code that we only pay for time trigger snapshots because we produce a lot of snapshots in door. I believe that everyone has seen. So we just do the initial check saying if it was an event trigger, I will not pay anything. So no rewards. If it was time trigger, then we are implementing the necessities of Door Metagraph. Like we will check if the device has made a check-in in the last 24 hours, if the address is already rewarded for that day, that we can pay only one time per day. So you can implement anything that you want as the reward logic there. But it's pretty much it. Like you can see that we are building the transaction sorted set at the end that will provide the rewards, the rewards array that should be the addresses and the amounts. And that's it. Once you do this, your tokens will be minted for the wallets that you want.
Yeah, so distributing rewards is ultimately as simple as just implementing the rewards function and then returning a sorted set of rewards transactions. So it's just the amount and what address it's going to. It's as simple as that. In this case, so this is the Door Metagraph. Like Marcus is saying, we're using this this sort of logic here to only look at distributing rewards on time-based triggers. Maybe Marcus, could you talk more about time-based snapshots triggers versus on demand?
Yeah, let's say like just like on Door, we are receiving a lot of updates on our Metagraph. So we need to produce more snapshots to aggregate all the updates. We have the 500 kilobytes limit per snapshot. And if we are accumulating too many updates in the single snapshot, we will exceed that amount. So we have a snapshot cutter that will try to aggregate the most update that we can inside a snapshot. And to not exceed, we will produce new snapshots. So that's the one thing that I was telling Bruno earlier, is like we can have multiple currency snapshots at the same global snapshot. And then this multiple currency snapshots is exactly this, like we are producing snapshots on demand, like by events. We are receiving events that are or updates, and then we are producing the snapshots. But we also have the time trigger snapshots. What is this time trigger? Even if we don't have any updates, we need to produce the snapshots. And the time trigger snapshots are a snapshot that was produced at every 43 seconds. We call epoch progress at every 43 seconds. It's one epoch progress. So at every epoch progress, we will trigger a time trigger snapshot. This can be used to pay rewards based on time, just like we have with Door. We know that one epoch progress is 43 seconds, so we can make the calculation to do like 24 hours, 30 hours, the periodicity that you want to pay your rewards. So time trigger snapshot, it will always be triggered at every 43 seconds. And that's exactly what we need for Door. So we made the calculus based on the epoch progress that I've mentioned and pay the rewards according to this. Is that clear, Alex? Or
Yeah, so there's two kinds of snapshots. The time triggered snapshots happen whether there's events or updates happening at all, so they could be empty. And those go about every 43 seconds. So roughly a minute, a little bit faster, and there's some variability there, so you can't depend on it exactly. But that's a really good way, or probably the best way that you have available to tell time on a Metagraph. You really can't use timestamps. That's actually a pretty big gotcha if you're putting some sort of a timestamp on, during processing of your event or your data update on the Metagraph. That's going to lead to forks really easily because each node is going to have a slightly different timestamp, and they're not going to match exactly. So if your client, right, your wallet or your external API that's sending data, if they put a timestamp and sign it and put it in the signed data, that's safe. But you can't use a timestamp within the Metagraph code because it won't be exactly the same in all the nodes. So what you do have available to you is these time-based snapshot rounds. This is the kind of logic that you'll want to tell them apart. And so for Door, what I was trying to show with this here is that Door is making about 10 snapshots per minute. And these are all on demand because there's a lot of data coming in. But there will be still that 43-second timed snapshot. So we don't know how fast these on-demand snapshots would come in. It could be 10 per minute. It could be 1 per minute. It could be 0. So we can't really use those to determine time.
yeah, like basing on ordinal is not secure. Is what Alex mentioned, like because ordinal can increase or decrease on demand on your Metagraph. So we do not recommend do this. And the gotcha that Alex mentioned about the timestamp is time is non-deterministic data. So you need to take care to use time even in your updates, because like Alex told, time can vary between the instances and the nodes, and this can produce different hashes, and these different hashes could reject updates, could reject consensus because it's non-deterministic. We don't know what is the right one. Both can be right, but with different times, the hashes will be different. Then we can have issues.
Yep, good. So yeah, this I think we started this kind of in response to one of these questions that was here in the channel. Just sort of, hey, how do we implement rewards or minting of tokens. Let's see, other gotchas around that. So
I think we have a question from Kevin on the chat, Alex.
oh great, I think since I'm sharing screen, I can't see chat. Let's see.
Yeah.
Does someone read it out?
So Kevin just asked, in the social metagraph README, it mentions that there's a private key that has to be provided, and is that something that has to be generated externally, or is it something that can be found when building the metagraph? And the short answer is both. You could generate a key, like a private key, and save that to the node and then load it in. But there's already or at Metagraph runtime, but there's already a private key that's associated and built into like Euclid to handle the node identification that can be read as part of the configuration parameters through environment variables. So you can read the same private key that is used to sign snapshots and use that within your metagraph to like do additional things. You have to be careful about doing it because it is that identity that that is signing data and moving things around on the lower level as part of the platform features of the metagraph, but it is accessible.
Yeah, you can think about that every update that will be ingested by Metagraph, every incoming update is signed for a wallet, signed for someone or something. I don't know. Like this private key is who signed the message. Like on Door Metagraph, on the Alpaca Metagraph, mainly on Door, each real device have their own key. So we have the public and the private key. So we signed the message using that private key, and then on the proofs, we provide the public key. So inside the metagraph, we do the confirmation to compare if the signature matches the public key. So we will check if the signature is really made for that content, if it was really made for that public key. So the private key is essential to sign the message, and then we can compare on the metagraph to see if the data is a correct data, is not changed data, is what we're expecting. So we have inner validations to confirm if the signature is right.
Yeah, so yeah, and this is the social example here. The reference to the private key is saying you need to have a private key that you're using to create or edit posts, delete. So that's what we have here in scripts. So all these examples have, or most of these examples have these scripts with somewhat similar code. You provide a private key, it shows how to sign and submit to the metagraph. So what this is doing is kind of replicating what in a real world application would often be fulfilled by like a wallet. So this could be instead Stargazer wallet that you're asking the user, hey, sign this data and then send it to the metagraph. So it's the user saying, I approve this data, it came from me, and we can keep that signature along with the data in order to prove that on chain. So I would definitely suggest taking a look at the voting poll example also. We covered it in a couple of the videos. The video that just came out yesterday is all about Stargazer and kind of how to do these kind of integrations. But this example, if you bring up the UI, it's using Stargazer wallet to sign data using a form within the UI, submit that signature with the form data, and then interact with the metagraph. So that's going to be a more realistic scenario for a real world app, is that you probably want to have that signature from the user. So that could be a user-based wallet like Stargazer. It could be, like in the case of Door, the Door foot traffic devices sign, or they have a private key on the firmware of each device, and they sign their data So no one has access to that private key except for that specific piece of hardware. And that way we can tell exactly where that data came from, and that it was signed at the source. So that's where these private key, or how the private keys would be used. I don't know if we show easily how to create one, but it's quite easy with DAG4.js, which I think is used here. So if that's something that's stumbling or like causing a stumbling block for anybody, reach out in Discord. We can link exactly some code snippets how to create the private key. You can also export one from Stargazer if you have an account set up.
And just a quick note,
I've seen in the
yeah, go ahead, bro.
yeah, I've seen in the daemon examples that when daemons pull data from external data sources, that they sign, like first they transform it into data updates of the metagraph, and these data updates are then signed by the node key, the layer 0 node key. But is that just because the layer 0 node key is already on the device, or is there any difference between submitting such a data update through the public data endpoint as opposed to request with an arbitrary wallet private key?
The Alpaca metagraph is a self-signing metagraph. So we fetch the data and we use our own key to sign the message and provide to the metagraph.
Yeah, so I think the kind of high level basic requirement is that all data submitted to the metagraph must be signed by someone or something with a private key. And so in the case of a daemon where you're running a timer and then fetching something from an external data source, that external data source can't sign it themselves since you don't control it. You're just collecting data. And so the only place that you can verify and say, we can sign it here, this is where we can verify the data's integrity going forward, would be at the node that collected it. And so that's why the node key is used.
But essentially using daemons from within the Euclid framework is just a useful feature with minimal code basically, but it's no different than building a separate process in Node.js or whatever that fetches the same URLs, signs it with a DAG4.js key, and then submits it to the layer 0 node with a post endpoint. That's exactly the same, pragmatically speaking, right?
Yes. Like
Yeah.
the advantage to use daemons is because we are centralizing this in a process that we run on our metagraph as a separate thread instead of having two different processes working in parallel. But it's pretty much the same, like have an external service that will fetch and everything, sign and send to the metagraph.
All right, cool. Thanks.
So it looks like we've got another question here. I think we're about to get to it without knowing Bob was on the call here, but we got a question. So Bob says, I'd like to mint a reward on an address on a per update basis. A client sends a data update, which includes a reward address. What would be the best way to accomplish this? Maybe using the calculated state in the rewards function. So yeah, I don't know who wants to take that.
Yeah, it's the same thing that we use for Alpaca and Door. We put the information that we want to reward on calculated state. On the rewards function, we have access to the calculated state. You can take a look. Yeah, rewards. You can open the Door rewards, please, Alex.
Sorry, Marcus, you're a little your mic's a little quiet.
Oh, okay. You can open the Door rewards, please, the class. Just to show that. Yes. Yeah.
Hey, this is Bob.
Yeah, hey, jump in.
Hey, yeah. Thanks for taking my question. A little bit more context. What I've got right now is every time a data update comes in on my application, my idea right now is to update the calculated state, like a little flag that says this address is due for a reward. And then when I get to the rewards function, I know I can access that, but I'd like to be able to then pay out the reward and update the calculated state so that like flag is then turned off.
Yeah.
Yep.
That's the same situation that we have with Door and Alpaca. We have access to the calculated state there. And here is where we can mention, again, the epoch progresses. Because you can flag, like on your calculated state, you also have access to the context function. And there you can put on the combine function saying, hey, I received this update now. I have this function, and on the combine function, I have the calculated state where I can put the address that I want to pay on the calculated state and the epoch progress that I want to pay the rewards. So I can put the information there, and then I can retrieve like on the rewards function to see if the epoch progress is the right one that we want to pay the function. If it's the right epoch progress, I distribute the rewards. If not, I skip. And then once I have the combine, I reach the combine function again, I can check on their calculated state, seeing if the rewards are already distributed. If it like the current epoch progress is greater than the epoch progress that you try to reward, you can just mark as paid the next iteration. So the combined function will be called even without updates. So this function is always called. So you can put like if we don't have updates or if we receive updates anyway, you can check on your calculated state to see all the updates that have the epoch progress lower than the current one. If it's lower, it means that it's already paid, and then you can just mark as paid.
Yeah, so the short answer is that you can't update state either on chain or calculated after the rewards function or in the rewards function. So you need to use a strategy like Marcus just described to indicate whether you should distribute rewards, and then on a later iteration or later snapshot, either mark it as paid or know that it was paid because that ordinal has passed.
Okay, yeah, understood. That could work.
Yeah, you
Thanks.
just can take a look at the example metagraph that both Alpaca and Door should have exactly what you need, like comparing epoch progress. Just take a look at the logic there.
Cool, perfect. Thank you.
That was one we ran into also during the development process, is that like, hey, wouldn't it be nice if we could just mark these as paid?
Yeah.
But given the way the lifecycle functions, or the order the lifecycle functions fire in, it's just not possible.
Yeah, you can think that state will only be updated on combine function. We don't have other places to update state.
All right, so we've got, I think, one final question in the chat here. We're sort of running up against the end of the hour, but the question is, so this question is not directly related to hackathon, which is fair game. Is it possible to define distance between two DAG addresses? Then is it possible to define reward/fee as a function of the distance? This will be somewhat similar to phone charges, depending upon whether the two phones are local or long distance. Well, I think we'd have to figure out specifically what we mean by distance. It would not be possible to figure out a physical distance, as in like where is someone physically located. In terms of distance in time, you could potentially look at the first activity at any DAG address, and you could do a time-based difference or distance. But I don't know. Does anyone else have any thought on this question? I'm not.
Yeah, I don't.
Sure.
The only type of distance parameters that I can think of, time I hadn't thought of. That's a good one. Or like, I don't know, hops or something like. Yeah, I can't even. Time is the only one that would make sense to me, because the distance of addresses are derived from elliptic curve public keys, so they're random by definition. So the distance would be, in any numeric sense, I think would be kind of be a meaningless parameter.
James, I think you can define Euclidean distance depending upon the time difference, then how many activities and things like that, something like that.
Yeah, that's possible. Time is a reasonable one. Like
Yeah, time
inactivity.
and how many activities have been done, and what's the geographical distance based on the IP address of creation or something like that. So there are various ways.
That one's harder.
Yeah.
Knowing the geographical distance,
Right.
unless you required like data update to somehow have an IP.
Yeah, this is not for immediate thing, but later on, it might be a good idea. I mean, this might be more research oriented in the sense that security and things like that. Okay, whether this DAG is in USA or in China or something, this is popular or this is no activity kind of things. So those kind of things. Yeah.
Yeah, you can
maybe build a
definitely
Metagraph that only supports data transmission through Bluetooth, and then you count the Bluetooth hops, and you have some physical distance because Bluetooth only goes so far. Not sure if you can just not send it through TCP/IP. I don't know if you can validate that or like fence that in, but Bluetooth may be some way to get distance in there.
Yeah, I think you could definitely build a metagraph that requires certain data, maybe IP address or Bluetooth hops or some of these other custom things, and then figure out your definition of distance around those. From just like a public network standpoint, the one that comes to mind is just based on activity on the network. But otherwise, there isn't that kind of information collected at all, like IP address or physical location.
Yeah, the Metagraphs is fully customizable, so you can provide any update field that you want. So maybe you can provide the IP, you can provide the geographic location or something like that. So you can provide that information, and then inside the Metagraph, you can do validations like, I will accept updates only for this range of IPs or something like that, or from a specific country. So yeah, you can provide this as fields on update.
Right. Well, I think that kind of wraps up our time. Looks like we don't have any new questions in the chat either, so that's good timing overall. Yeah, appreciate everybody who hopped on and joined and participated in this. I feel like had a pretty good discussion here. Just reminders, there's one more of these office hours next week. So that we'll send a reminder email, we'll post in Discord on schedule on that, but it'll be similar setup. Also a reminder, if you need any one-on-one help, we do have a Calendly link available. You'll be booking time with either Marcus or James. So make use of that over these next couple weeks. We've just got this week, next week, and then following Monday is our hackathon submission deadline. So time's getting short. Seems like a bunch of you guys are making some good progress. So just feel free to make use of those resources and get whatever help you need to kind of cross the finish line. And yeah, thanks everybody so much for joining. We'll see you.
Thanks everyone.